Alright guys, we're back after now that we've done our empirical and molecular calculations, right? We know about our chemical formulas. So what we're going to do now with kind of, this is the Unit 4B really. I'm going to call it Unit 4B because we're going to kind of work on similar standards. It's just that we're kind of leaving our empirical molecular standard behind, okay? We're going to keep on, it's going to be similar things. So it's all about chemical reactions and stoichiometry. So hopefully, right, you have filled out this page here, right? We should know about chemical and physical changes. We've probably heard about them in like middle school science. Hopefully we watched the Bozeman science video and filled out some of these notes, right? We should be able to fill them out on our own. But let's start to look now at our types of chemical reactions, okay? We've got 4 types here, and we're going to add one more, actually, at the end, right? So our types of chemical reactions, hopefully we watched the Flintstones video. The Flintstones video really kind of explains what some of these reactions are, okay? So our single replacement reactions, basically one ion replaces the other, or replaces another. Okay, so we've got a few examples here. Let's go through some of these. So if I look at silver versus gold 3 chloride, gold chloride, I know that silver and gold are similar ions, right? So for an ion to replace another one, it has to be similar, okay? So silver and gold, silver is going to come in and it's going to kick gold off. So my silver will kick gold off, and it is going to then form a chemical bond with chlorine. So silver always has a +1 charge, chlorine always has a -1 charge, so we're going to have silver chloride. Now, I know that we're going to get 3 of them here because I look and I see 3 silvers and 3 chlorines on this side. We're going to talk about balancing our chemical reactions next time, okay? But we've got 3 silver chlorides that form, and then what we kick off, of course, is our gold. Okay, so we've got gold that is sitting over here by itself, and then our silver is combined, chemically combined with our chlorine. Let's look at our next one. If I look here, I have chromium and H2SO4. H2SO4, that would be hydrogen sulfate, or dihydrogen sulfate, right? And so I know that chromium as a metal is going to form a positive charge, right? It's always going to form a positive charge. And in this case, it's going to form a +3 charge. So if chromium is going to go to a +3, I look over here, what is my positive ion on this? My positive ion is my H+ here, because my SO4 is my polyatomic. SO4 is sulfate with SO4 2-. So each of these hydrogens have a +1. So I know, right, if chromium is going to form a positive charge, it's going to come in and it's going to kick off my H+. That's what I mean by it's going to kick off a similar ion, okay? So chromium is going to come in, it's going to kick H+ off, and we're going to form a bond between chromium and SO4. So it's going to be chromium 3, SO4 with a 2-. I do the swap, right? I would say chromium 3+, SO4 2-. So I need, to get this to be an uncharged formula, I need 2 chromiums, Cr2, and then SO4, I need 3 of them, SO4 3. And then I kick off hydrogen. Hydrogen is going to be all by itself, right? But hydrogen, when it's all by itself, hydrogen is a diatomic. So hydrogen is a diatomic, so it's always going to be H2, all right? So if it's H2, if I then look here, I'm going to have 3 H2s that get kicked off. Remember our 7 diatomic, right? We've got 7 up. We start with element 7, that would be nitrogen, and we go make a 7, oxygen, fluorine, chlorine, bromine, iodine. That's 6. Our 7th one is up at hydrogen, okay? So we're going to have to remember that. So back here to our single replacement, right? Now let's look at this next one. Now, again, we need to identify the element that's going to get kicked off. So chromium, again, is going to form a positive charge. It's a metal. So it's going to kick off the metal, the positively charged metal that's in this iron carbonate. So this is iron that's going to get kicked off. So we're going to have iron that gets kicked off. We're going to put that over on its own side. We're going to have 3 of them. And then we're going to have chromium carbonate. Chromium, again, is going to form a +3 charge, and carbonate, CO3 2-. So if it's CO3 2-, we're going to have Cr2, CO3, 3, so we have an uncharged formula. Again, guys, we have to make sure that our compounds have an uncharged formula, okay? So overall, what our reaction is going to look like is something like AX plus Y goes to AY plus X, or AX plus B goes to BX plus A. So if we look here, right, this would be this would be kind of this would be AX and this would be B. So B kicks off A, and this would be X left over. So let's show that. That's AX plus B. So this is AX plus B. We're going to have BX combined plus A over there. Okay, so that's how we have a single replacement. All right, let's look over here now at our double replacement. Double replacement, we have 2 ions that swap places. Okay, so if we notice here now, right, each of our compounds has a positive and a negative ion, a positive and a negative ion. Those positives are going to switch places. So, or the positives are going to switch places with the negatives, okay? So our examples here, we see lead nitrate and sodium chloride. Lead is positive, sodium is positive, nitrate is negative, chlorine is negative. So lead now is going to combine with chlorine. Lead starts out as a +2 here. How do I know that? I look at my nitrate. Nitrate has a -1 charge, and I've got 2 of them. So lead has to have a +2 charge. That means that I need 2 chlorines to have an uncharged compound over on the right-hand side. I also then am going to have sodium combined with nitrate. And again, I'm going to have 2 sodium nitrates. It's going to balance out at the end. We got to make sure that we have a balanced form or a balanced reaction at the end. We're going to talk about that more next time. Let's look at this second reaction here. Again, we've got a positive and a negative, positive and a negative. So this positive is going to combine with this negative, and this negative is going to combine with this positive. So let's write our sodium combining with, oh, that's nitrate again. Well, that's NO3. Sodium is a +1. Nitrate is NO3 with a 1-. So we've got sodium nitrate. And I'm going to end up having 3 of them when I balance this reaction. And then we're going to have silver combined with phosphate. Silver is always a +1, so I'm going to have silver there. And then phosphate is a 3-. So I need 3 silvers, Ag3, PO4. Okay? I need 3 silver ions to balance out the charge of my PO4. All right? Let's look at this next one here. K2CO3 plus 2AgNO3. Ag is positive and K is positive. K plus, Ag plus. So let's do a swap, right? Let's put potassium, oh my gosh, I can't even write. We're going to have potassium combined with nitrate, so KNO3, and I'm going to end up with 2 of them, so I'll have a 2 there. And then I'm also going to have silver combined with carbonate. So silver, again, always has a +1 charge. Silver always has a +1 charge, so let's go look at carbonate. Carbonate is CO3 2-, so I need 2 silvers, Ag2CO3. Okay? So what it's going to look like is AX plus BY is going to go to, right, this is going to do a swap, so AY plus BX, okay? Again, something that we really need to focus on is that each of these compounds must be uncharged. So we need to know the charge of our polyatomics. For the charge of our metals, if it's group 1 metals, like potassium or sodium, that's always going to be +1. If we know silver, that's always +1. But our transition and our post-transition metals, we have to look at the anion that it's combined with to know what the charge is. So nitrate is a -1. I've got 2 of them. So this has a -2 charge overall. To balance that out, lead has to have a +2 charge. Okay? So make sure that we look at the charges to know what, so that we know what compound we have. Okay? I'll be back in a second.